In each of 3 through 15, a sequence is defined recursively. Use iteration to guess an explicit formula for the sequence. Use formulas from section 5.2 to simplify your answers whenever possible. G sub k equals G sub k minus 1 over G sub k minus 1 plus 2 for each integer k greater than or equal to 2 and G sub 1 equals 1. Now, iteration is the best way, in my opinion, to try to guess an explicit formula. The way we're going to do this is we're going to solve for G sub 2 and G sub 3 in terms of G sub 1. We know that G sub 1 equals 1, but we're not going to replace G sub 1 with 1. We're going to instead write all of the other terms in terms of G sub 1. So for example, G sub 2, according to the recursive definition, is G sub 1 over G sub 1 plus 2. Now, yes, this is 1/3, but in order to guess an explicit formula, it will be easier to leave this as is. And now we're going to write G sub 3 in terms of G sub 1. We can use the recursive definition to write G sub 3 in terms of G sub 2. So this is G sub 2 over G sub 2 plus 2. But we can substitute G sub 1 over G sub 1 plus 2 into both of these G of 2's so that we can write G sub 3 in terms of G sub 1. Now this is kind of messy, but we can simplify this fraction by multiplying the numerator and the denominator, both by G sub 1 plus 2. And so G sub 3 is G sub 1 over G sub 1 plus 2 times G sub 1 plus 2. And this simplifies to G sub 1 all over 3 G sub 1 plus 4. Now let's calculate G sub 4. G sub 4, according to the recursive definition, is G sub 3 over G sub 3 plus 2. And we can plug what we got for G sub 3 into this G sub 3's here. And so we get G sub 1 over 3 G sub 1 plus 4 over G sub 1 over 3 G sub 1 plus 4 plus 2, which we can simplify this the same way we simplified the last two fractions by multiplying the numerator and denominator by 3 G sub 1 plus 4. And so we get G sub 4 equals G sub 1 over G sub 1 plus 2 times 3 G sub 1 plus 4, which simplifies to G sub 1 over 7 G sub 1 plus 8. And now we can start seeing a pattern here. If you notice, the thing that we're adding in the denominator is always a power of 2. And the coefficient attached to the G1 is 1 less than that power of 2. And so if I were to predict G sub 5, I would guess that G sub 5 would be G sub 1 over the next power of 2 would be 16. And so this would probably be 15 G sub 1. Now we can generalize this formula by saying G sub n equals G sub 1. If you notice, the numerator is always G sub 1 over, and now I'm going to do the second number first because these are powers of 2. Now, when the subscript is 4, we have an 8, and when the subscript is 3, we have a 4. 4 is 2 squared, 8 is 2 cubed, so it looks like it's always 2 to the power of whatever the index is minus 1. And then plus G sub 1, the number that goes in front of the G sub 1, though, is 1 less than that power of 2. So again, this is just a generalization of the pattern that we're noticing. I'm noticing that this second number is a power of 2, and the coefficient on the G1 is just 1 less than that power of 2. Now that we've generalized G sub n in terms of G sub 1, we can now back substitute. G sub 1 is just 1. So we can replace the G sub 1 with 1, and then we can simplify this by grouping together the powers of 2. And just to illustrate this next step, I'm going to factor out the 2 to the n minus 1 in that denominator, just from the parentheses part. And then 1 plus 1 equals 2. So this is 2 to the n minus 1 times 2 minus 1. Now this other 2 has an exponent by default of 1, so we can use the law of exponents to add the exponents together to get 1 over 2 to the n minus 1. And this is the explicit formula for g sub n. Thanks, everyone, and I'll see you in the next video. Now, I will say that the pattern to g sub n could probably be determined more easily if we just look at the sequence itself. If you notice, the denominator here is just 2 to the n minus 1, and this is a pattern that we had to find anyways. In particular, the coefficient to this g sub 1 is 2 to the n minus 1 minus 1. And so using iteration here is actually pretty inefficient and probably not the best way of solving this problem, but it still works. Thanks, everyone, and I'll see you in the next video.